In the last video, we done the calculation for minimum steel requirements for using AS3600, where we check that 395 millimeter square and 435 millimeter square that are satisfying the minimum steel requirements. So it was greater than AST minimum. Now there is a one more check that we need to making sure that this 395 is enough to control the crack due to the shrinkage and temperature effect. We should make sure that AS3600 have provided the reinforcement to control the crack for shrinkage and temperature. So we need to make sure that 395 millimeters, is it enough to control the crack and temperature, or 435 at here, it is enough or not? So that's again we're going to check it for using the AS3600. So if you go to the clause 9.5.3, it will have this crack control for shrinkage and temperature effect. So reinforcement in the primary directions, we are working in the primary direction. So there is a clause here where it's talking about 9.5.3.2 is a reinforcement in the primary directions. If you are in the primary direction, if you just read these 4-5 lines here, it says that 75% area required by one of these clause, that is 9.5.3.3, that is secondary directions for unrestrained slab, and we are for the restrained slab, so we are going to use 9.5.3.4. In that one, there is a different exposure conditions are given here. In our example, there was no any conditions. Let me read that one. If there is a given any conditions, there is no any given conditions for the exposure conditions. So we are assuming this moderated degree of control over the cracking. So that's assumptions we are making it here. So in that case, AST should be greater than 75%. Where is the 75% coming? There is 75% of the area. So 75%. 3.5 take away 2.5 sigma Cp Bd times 10 to the power 3. Now sigma Cp, that's the one that we need to talk about. I think if you go to the start of the standards and on page number 31, you will find that sigma Cp. Let me take you through that page number 31 where they talk about this sigma Cp. There you go. Sigma Cp is the average intensity of effective pre-stress in the concrete. In our examples, we don't have any pre-stress, so we are taking sigma Cp equal to 0. Go back to the clause 9.5.3. So in here, we can just put sigma Cp equal to 0, converting 75% into the number. So just dividing by 100. 3.5 take away 2.5 times by 0. Sigma Cp is 0 because no pre-stress. Width of the slabs, I think we are just taking 1 meter wide strip. We are taking 1 meter wide strip, so we are taking B equal to 1000 millimeters. Depth of the slabs, I think in the previous videos we calculate this depth of the slab, ds. I think I show it to you here. Depth of the slab 190 millimeters, so we just put that 190 millimeters here, times by 10 to the power 3, and that's 10 to the power 3 is coming from here. Now you can just cancel this thousands, so it's basically 3.4 times 190 times 0.75, that will give you 499 millimeters square per meter. So the standard saying that you must provide 499 millimeters square per meter reinforcement in your slab to control the crack due to the shrinkage and temperature effect. Right, now this is again independent to your slab locations. This is again independent of slab location. What does it means? It means that anywhere, if you are talking about here, or if you are taking slab here, or anywhere in the structures, your reinforcement is this is independent. So we no need to do the separate calculations for here and here. These calculations is valid for your slab. So let's check. In the previous videos, we calculated the area of reinforcement at the midspan, 395 millimeters square per meter, and it has passed through the minimum reinforcement requirement. So it was okay for minimum steel walls requirement 395 millimeters square per meter. But when I come back and check and compare against 490 by standard saying that you must provide 499 millimeters square per meter reinforcement, but our calculation indicate 395. The bending resistance calculation indicate 395 millimeters square. So that is not okay, right? We need to have at least 499 to control the crack. Our beam will crack if you provide 395 millimeter square per meter in the shrinkage and temperature. So to stop the cracking the slab for shrinkage and temperature effect, we must provide this 499 millimeter square. So I'm changing this one 399 to 499 millimeter square per meter. 435, check it here, we calculate this 435 millimeter square per meters, and those 435 millimeter square per meters was okay for minimum steel reinforcement, was satisfy the minimum steel requirement, which was preventing the collapse. But it's not satisfying the crack control, because your slab will going to crack here at this particular locations if you are providing 435 millimeter square per meter. So it says that okay, if you provide this one it will crack, but if you provide 499 millimeter square per, it will not gonna crack. So of course we're going to use 499, because less than that we're going to provide the 499 millimeter square per meter. So now this number is not anymore 395 millimeter square per meter, we should have 499 millimeter square per meter, and we don't need this 435 millimeter square per meters, we can provide 499 millimeter square per meter. In the next video, now we're going to do the calculations for spacing, because now we know the area is here, same area is same here, so now we know the area. So now we're going to do the calculations for the spacing, the spacing between the bar, and also standard has a requirement for minimum spacing, that also we're going to check it. Thank you.